I'm Miodrag. I'm CTO in Limundo. I guess some of you probably knows what Limundo is and what Limundo does. How many of you do know Limundo? Oh, nice. How many of you use Limundo? Oh, okay, very nice. Then I will not speak too much about the business model. It's a e-commerce sites actually, Limundo and Cupindo. Limundo is an auction-based system, and Cupindo is a fixed price system. We split them into two sites. There are some other modules like Limundo Cash, which is a escrow system with a plans to become a wallet, etc. But at this time, I would like to present a little case study on a Limundo architecture. And well, it is a convenient that this presentation is last because there are some, I believe there are some implementations of the techniques or examples of the techniques that other speakers spoke about today, earlier today. Anyhow, Limundo is run on PHP currently from the beginning. So one of the things I'm going to show here is that you can have applications or systems run on PHP that are pretty intensive in bandwidth wise, high performance wise, etc. As you can see here, in peaks are Limundo must have the biggest visit and sales during the autumn and winter. During the summer, activity drops down, and daily wise, the biggest activity is after 8 p.m. During peaks, we have up to 10 million page views per day, up to 10,000 users per second, and there are three main demands that are put before us. Limundo and Cupindo, whole system, must have a high speed. It has to be quick. Web pages must open under 1 second in average. So it has to run fast. It has to be stable. In this case, it is actually failover. So if some servers fail, or if you lose some percent of servers or network equipment, end user must not feel that. The system must run as smoothly as it ran with the full service until we manage to solve the problem. And it has to scale out to be scalable, because we are each year we are growing up to 50% on a year basis, and we are planning to accelerate that growth. So if we don't scale linearly for starters, we will soon end up in a situation that we will need. If the number of visits rise 2 times, we will have to have 3 times more service. We will run out of service eventually. So we have to scale out nicely. There are some other issues that are not shown here, but one of the most important issues is security. I wanted to mention that as well, because today I didn't hear much about that. But I believe that in today's world and tomorrow, security will be the most important thing. Today you can create just about anything, as we heard. We have ready-made tools for just about anything. You can use ready-made frameworks. You can create your own YouTube, whatever. But the main issue here is what about the data that are being inside? The data must not be compromised. They can be compromised in many ways. Direct intrusion into the databases with all those terabytes of data, session hijacking, someone stole your own identity, not only Limundo, but in banks, e-banking, etc. And since we recently put out an API, someone can use the API to extract the data and use them from some malicious purposes. Anyhow, all this load, 10,000 users per second, and etc. that is written here, is achieved by several clusters of servers, which are shown here. There are several more. There are about 40 servers here. There are more servers for email servers, backup, etc. But they are not so important. most of this structure is virtualized. I will repeat this several times: speed, failover, and scalability. We did migration last year, December last year, from the data center in Germany to Serbian data center. It lasted about 9 months, and it spent about 40 months was spent on designing the whole thing and moving the thing to Serbia. And most of this infrastructure is virtualized because of the speed, much better utilization of resources. So if some servers are idle, other servers can use their resources, their cores, their memory. For failover, we can span new servers quickly. At this time, we are doing it manually, but under 1 hour, we can span tens of servers if we need them. And scalability, these are virtual servers, so they scale. At this point, they scale pretty nicely. We can add tens or even hundreds of servers, and it won't hurt us financial-wise, and that is also budget-wise. That is also very important part in the whole story. I will go through each of this cluster. We'll tell a little bit about each of them, and I will try to reflect on the things we heard earlier. First, there is the load balancing cluster. It is behind the firewall, of course. It is not that important. Firewall filters the outside world traffic. Load balancer servers, they are Nginx servers, compact web server, which is fast, which scales good. It has a minimal functionalities, so it runs fast. Failover is all these machines, these 4 machines, 2 times 2 because there are 2 for Limundo, 2 for Cupindo. Currently, they are in active mode, which means that each of them is receiving traffic and they all work at the same time, which provides failover through a keep alive daemon. It touches these servers every 30 seconds, and if it sees that some of the servers is down, it automatically removes it from the rotation, and the rest of the servers will take its bandwidth and load. What is important is that in every failover situation, we must have at least 100% space for the increase in visits or decrease in number of servers, and that so the factor of 2 must be provided, and it also must be looked at the peak traffic. Because if you lose 1 or 2 servers and your whole system becomes to slow down, it is not really a redundant system. It is not real failover. System must work with the same speed, with the same functionalities, even with the 50% of its resources down. And it must also do this in peak hours, peak months, not only in times where there is no traffic. So when we calculate the number of resources we have to have spare, we must look at the peak hours, peak loads, which is important thing to mention here. These instances, these are virtual instances. As I said, most of the infrastructure is virtualized. The MySQL servers are not. We will get to that later. These instances are stateless, which is also very important, which means that each of these servers is completely identical. We can clone any of it, not only this cluster, in any cluster. We can just clone it, put it into the network, and it will work without any further setup or anything. So basically all of our instances are stateless to allow for a quick cloning and quick adding of resources. Right now, we are doing it manually. We are now researching into a solution that will allow dynamical allocation of resources like processor cores, memory, and similar across the system. If some servers are experiencing high load, some others are not, the system should be able to automatically reassign the cores to the cluster that has a bigger load. So keep live daemon is touching these servers constantly, and it will remove it from the rotation if it's down. The whole content is zipped. It is important for the speed and for the bandwidth, for the speed basically. So it is the speed part. It is all content is automatically zipped and compressed when it's sent to the user. SSL is terminated here. It's just to mention that. So these load balancers are doing SSL termination. We are currently looking into NetScaler hardware or virtual machines to use instead of these load balancers, but it is still we are still researching it, so no, I don't have any real case study about that, but we expect it should be able to improve the speed by 1 or 2%, which is not irrelevant because these numbers are adding. If we manage to shave off 1% on 15 small spots, it's 15% overall increase the speed, which is good. Load balancer servers are serving web pages, HTML pages, which come from the web servers, and images which come from the storage. This setup is made so that images can be served from CDNs, content delivery networks, in the future if we expand geographically, so that CDN will have a meaning in that case. Next clusters are web servers. Right now there are about 15 web servers. They are also active, so they all serve the traffic. They are serve Limundo and Cupindo traffic because of the better usage of resources. So Limundo and Cupindo are separated business-wise. It is a business decision, but IT-wise we actually put them all in the same network so that we can allocate resources better. PHP is running. These are basically application servers. PHP running here. This APC line is from yesterday actually obsolete information. APC is PHP caching. It creates it compiles PHP into bytecode and store it into memory, which is important because right now web servers are pulling about 100 million PHP pages per day. So if they were on hard disks are always bottlenecks. The whole system would explode. So APC caches PHP bytecode into memory, and web servers and PHP, not PHP, interprets serve these PHP pages direct from memory. As from PHP 5.5, we installed it. We put it in production actually yesterday, after a couple of weeks of researching and ironing out the incompatibilities with the previous versions. It has its own caching algorithm, opcache, which to our measurements performs better than APC. APC is not native to PHP. It is third-party software. Opcache is native to PHP. It performs better. PHP 5.5 also implements serialization, native serialization algorithm, which was also earlier used as a add-on module. And we had very, very good results with this. With PHP 5.5, load average fell by 5 or 6 times, which is almost unbelievable. Load average, I guess you know, but load average is we use load average to monitor our service. It's a number of processes that are currently being in process that are working. So if you have 8 cores in machines, load average of 8 means you have 8 processes. Each core runs 1 process. You have optimal situation. If you have load average less than 8, you are having idle cores. If you're having load average more than 8, in 8 core example, you are having bottleneck because processes are beginning to stack and to wait for the others to finish. So we have up to 500% improvement in load average and some 10 to 15% improvement in CPU, which is actually very, very good. So PHP 5.5 at this point proves to be very, 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 very good, yielded very good results. We did have to iron out some incompatibilities. Most of them are strict errors. PHP 5.5 introduced strict standards. We solved most of them by turning off the strict warnings actually, but in some time we hope to iron out that part completely. On web service, we are running Apache. Like Nginx, it is more robust. It can do more things like hosting mod PHP. We are using MySQL and the master slave add-on to access MySQL cluster. It is secured against Linux. We are using JPEG Mini, which is also maybe interesting to know. JPEG Mini is a third-party service that compresses, we are licensing it, that compresses JPEG images up to 40 to 50% in size while retaining the quality without losing any quality. The problems we had with JPEG Mini is that it's slow. It obviously does lots of computations. It is its licensing model is it constantly pings it phones home constantly to confirm that it is licensed. So we had to cache the license requests, and we had to postpone to process the images up to 24 hours after they are uploaded. But we get up to 50% smaller images and smaller images in kilobyte size, which is also good from some other reasons. We will get back to that. As a key, we use Redis as a key value cache store. These machines are active passive, if you noticed. The plan is to promote it to active, but it is not of priority right now because Redis is doing a fantastic job. We are using it as a in-memory cache. We are caching all stuff like item description, etc. Right now we are having some 1,200,000 items active on Limundo and Cupindo, and 1 million more on 1.5 million, so almost 3 million items are stored on our systems. And basically all of these items are cached in Redis and are being served from Redis in under 0.2 seconds without going to other clusters to show it. We also use Redis as a session storage. Also sessions when written to disk is bottleneck. So once again, speed. We moved session to Redis memory. So and all web servers are using the same session storage. So when load balancers pick various web servers when you visit the site, or change web service while you surfing the Limundo and Cupindo, your session remains persistent. So you are logged in. You don't experience any log out or any strange behaviors when the session, if that will happen if the sessions got erased. It also has keep alive daemon which same goes for the web service that touches these machines constantly. If the machine goes down, it's removed from the rotation, and other machines take the traffic and the computation, and it's all done automatically. As I like to say, I think Bill Gates said that that it is wise to employ lazy people, because lazy people will go great lengths into creating systems that works by themselves. And as I said earlier, we have peak hours at 9 p.m., 10 p.m., 11 p.m. So the biggest probability of a failure is around 11 p.m. or midnight. And we don't want to get up at 11 p.m. or midnight or 1 a.m., which happened a couple of years ago, to keep the system up. So we have good motivation to create I'm talking about IT-wise and all other sectors, of course. We have good motivation to create automatic system that will do automatic failover, that will automatically distribute the resources, so that the whole system can work as fast as before until at least morning of the next work day, when we can get to the work and see what happened and remedy the damage done. Redis servers are in replication. Right now there are only 2 virtual machines. Actually, we don't need more, just for the sake of redundancy. So we are very, very, very pleased with the Redis. Next, we have search and indexing cluster. We are using Sphinx as our solution for indexing and searching. It is being, Sphinx servers are being targeted through HA proxy, high availability proxy, which also detects when some machines are down or they are clogged, so they are removed from the rotation once again as before. So that's about failover. About scaling, same as before. These machines are stateless, active. We can clone them manually pretty fast. In an hour or two, we can clone 10 more of these machines, add them to the cluster. Of course, it will cost us. We are paying basically per core. So if we add, we are counting everything by cores, processor cores. If we add 10 machines with 4 cores, with 8 cores, it's 80 cores. That costs that much per core. Sphinx server are hosting Search Daemon, Sphinx Search Daemon. Sphinx is a service that indexes data that are stored, in this case, in MySQL. It creates binary files which are, and Search Daemon uses them to perform extremely fast full-text searches. So we can search through hundreds of millions of data. I'm saying hundreds of millions because we have 4 million items, but all these items have characteristics, colors, which are all lookup tables. All are systematized. Color, size, memory, depends on the category. There are about 1,000 categories on each site. So we are talking about hundreds of millions of data. Sphinx searches through this data very, very fast and returns the IDs of the items, which are then scooped from Redis if they are cached there, or from MySQL directly if they are not cached, and they are cached in Redis for future use. So Redis we are using LRU algorithm recently used. Items that are not being touched for some time are being expunged from the Redis cache. With Sphinx, we also used with Sphinx we had problems because it appeared that it does not use resources well enough. It has, for example, 8 core machines, but it does not use all 8 cores. It is a problem with Sphinx. We are using it for over 4 years. It is now native to PHP. 4 years ago, it was not native. We are now looking to remedy this problem by splitting our machines, for example, from 8 cores to 2 4-core machines. To achieve scale out through simple physical splitting of the machines. That is one problem we are experiencing with Sphinx. It is fast, it works. We are generally satisfied with it, but at this point we are looking to improve its scaling. So via speed we got covered. Scaling and failover we are now looking to improve. There are new version 2.0 came out. We are now using 2.06, I think. So we are now researching that as well to see whether it will remedy these problems. And we also had to use data. We manually created data partitioning so that main index is split into groups, something like MapReduce, but we were doing it manually at this point. Is split over the servers, so the search is parallelized. When you search something, all 15 servers are computing it and returning you the data sets which are joined and shown to the user that is browsing the site. So Sphinx server sends its data to web servers basically, and it gets its index, search indexes from DB cluster. They are stateless, they are active as I said. We are looking into Solar. We will see if it will fit our needs, but this is basically we have a lot of code in Sphinx, so it is inherited, lots of inherited code, so it will take a lot of time to refactor that part, but we are doing it step by step. NFS storage, we have, this is the main storage, NetApp, that are used to store images, and images use most of the data, about 5 or 6 terabytes, or about 5 or 6 terabytes, and there are some other static PHP code, etc. So also all web servers have one central repository for a PHP code. When we upload the code, we upload it to a storage, and it gets cached on the web servers. It has an array of SATA disks. It has SSD caching. SSD is of course much faster than your regular mechanical disks. SSD disks are quantum machines, so they have no moving parts. They are fast and expensive, so they are used as a cache, and that's where the duplication cache is a couple of hundred of gigabytes, not more, and that is where the duplication comes into play. Most of you probably know, but the duplication is a process where storage has its own, of course, its own logic and processor units, processor cores, etc., where it finds out the duplicate files. So if you have two files which are identical, two file handles, the duplication will find out these two files, will erase the second file, and will point the second pointer to the first file. So you have two file handles, one file, which is okay. It saves space, but it's actually much more important for speed, because we have limited caching space. So if you have 10 identical files, without the duplication, you would have to cache 10 files and take out expensive space. With the duplication, you're actually caching one file, and you have 10 pointers that point to the same file. So it actually improves speed. It has the storage is a box that has everything in doubled electricity, etc. So we have redundancy here as well. It takes snapshots mostly of code. Images are being backupped and rotating on a daily basis. There are a lot of images, so right now we cannot hold the backup of everything indeterminately. And finally, MySQL database cluster is the most deep. It is not by accident placed there. These are physical machines. When we were doing migration, we did not want to virtualize these machines. They hold the relational data. So everything else, Sphinx, Redis, web servers, all other clusters can lose their data completely. We can rebuild them from the data from MySQL cluster. MySQL cluster holds the relational data. It holds data and holds data and the relations between them. And that's why we opted to have them as bare metal machines. In some time, we probably will virtualize them as well. We will have to have a storage with dedicated bandwidth for MySQL. These are Percona fork used. After analysis, we decided to use Percona fork as it performed better than vanilla, to say MySQL 5.5. MySQL 5.6 should have similar should be very similar to this Percona fork. So these machines are critical. They must work. We must not lose them. Once again, because of the failover, they have 16 cores or more, I think. Because of the failover, we have two masters in multi-master applications. So if one master fails, the other master automatically is promoted to primary master, and the users will not see that anything happened. We actually had a pretty serious incident, to say, a month ago when 3 machines went dead. It seems that the whole series had issues, which happens, but nothing was shown everything went smooth from the outside world point of view. It took about 24 hours to replace them all, but everything went went, as I said, nothing could be seen from outside. There are 3 MySQL slaves. Masters receive insert, slave receives selects. Basically, one of the slaves is used primarily for CMS, local admin software, which is also interesting lesson learned. Admin software that is used by our employees, 40 of them, for various things. They use it to monitor the items, fine-tune the categories, etc., etc. It has some very complex queries. It loads the machine much more than the site itself, and that's why it's isolated. Employees can wait 5 seconds to have their complex request to receive the result. The outside users must not wait more than a second. So one of these machines is used solely for admin, and admin part can be moved to other machines, and we have enough spare resources to make it tick, even if the CMS machine goes down. But just in case, as we detected a much bigger load from admin software CMS, we isolated it on one of these MySQL slaves. Multi-master application is used as a service that constantly is querying all these servers. If it detects a jump in the load or replication delay, or that machine is dead, it will automatically remove it from the rotation. It will assign virtual IP to other machine, and everything will work automatically and seamless for the end user. InnoDB storage engine is used, which is a strong recommendation for any future MySQL usage. Since Oracle bought MySQL, they improved InnoDB very much. InnoDB allows row locking, which is a must to have in any performance system. When you update a row, you don't want to lock the whole table just to have one row updated. Sphinx indexer is running in order to save the resources. We are using secondary master as a Sphinx indexer machine. A Sphinx indexer is very CPU. It uses lots of CPU, so it runs on the secondary master and constantly indexing MySQL slave content. Some indexes are being rebuilt every minute, some every 3 minutes, some every 1 hour or every 24 hours. Also, Sphinx works, basically with Sphinx you want to index the whole database, so all 100 million rows, but it will take time, obviously. So what we are doing, and what Sphinx is offering support for, we have one main index once a day, and we have delta indexes every like 5 minutes, 15 minutes, depends on the complexity of the indexes, and they are added to the main. They are adding differences to the deltas are adding differences to the main index, which allows us to have data relatively fast. And that's why, for example, if you put up an item on Limundo or Cupindo, it might take up to 1 hour for it to be visible in search. Depends on where in what time segment. We have some 10 different indexes in where you fall into this time span of indexes. And also critical calculations, which are actually it went out from the screen. Which are actually financial calculations are running on MySQL master, because we don't want to have any issues with money transactions. If it can, any replication is not instantaneous. Even in ideal situation, it lags. It lags 100 milliseconds. If it lags 1 millisecond, whatever. But it can happen that if you are pulling information from slaves, slave didn't pull the replication data from master, and you have the wrong financial data. So financial calculations are being run on a master, primary master, whichever of these machines it is. So it is a basic overview of the architecture. As I said, there are several more servers, not that important. And also we are doing some research into 2 more clusters. Since we launched API for Cupindo, which exposes all of the functionalities for Cupindo, developers can now register on Cupindo and use the API calls to create their own apps, applications, whatever. The API works through RESTful interface on OAuth 2 authentication. So it serves JSON or XML, whatever you want. So it is a pretty much standard thing. The same thing you are doing with Facebook or Twitter. If you if you use their API, this is Cupindo API is basically the same thing. And we are using it internally already. We launched Cupindo widget on Limundo to test how it works. And what is important, basically developers now can make some interesting things. For example, on eBay, I remember 5 years ago, I think there was an interesting usage of API. Someone created an application that was searching for misspelled items on eBay. For example, not iPhone, but IH phone. So the guy who sold iPhone mistyped the name. This item cannot be found easily in searches because people are searching for iPhone. So its price will be much lower than the correctly spelled items. This guy managed to find all these misspelled items, to buy them and to resell them at a market price and to earn a substantial amount of money by using the API. And he developed whatever kind of algorithms that were able to detect this kind of misspelled names. However, with API, we have a whole new area of problems, like rate limiting, like security. We don't want someone to pull out the data and investigate it in any way. So we have to log a lot of data. So we plan to, and we have to process it fast. We are now putting up a Mongo cluster as a solution to store millions or tens of millions of data per day and to rotate it daily or monthly. Mongo is our choice at this moment because of the performances. So it has to be done quickly. When you are issuing your API queries, and if you're over a rate limit, you don't want to wait 5 seconds for our system to tell you, hey, you are over rate limit. It's over rate limit. It has to be done instantaneously. So that is why we are planning to use Mongo for this kind of computations, and some other, for example, the number of page views for items. It is actually increment. It increments. It's simple increment of the number of views, but in MySQL, or it's you have to select the data, increase it by 1, and put it back into database. That is how it works behind. With Mongo, we should be able to just increment it directly. And in the long run, we are now researching on Hadoop cluster because we want to store all these other data logs, to store it for a longer time and to be able to compute, to calculate, to process it. Because amongst other things, our main strategy, main concern is to make Limundo and Cupindo a secure marketplace for sellers and buyers. So if you register on Limundo and Cupindo, the chance that you will get fraudulent bad item, or you get marked to say is smaller than if you go to the marketplace in real world. And for that, we have a lot of people and a lot of algorithms that are trying to detect fraudulent activities soon enough and to stop them before the real harm is done. Also, when someone is banned from Limundo or Cupindo, some user, some member, because of the not following our rules, he is forbidden of registering ever again on it. So we also must detect registrations, the repeated registration, etc., which also involves lots of computations, lots of data stored. So that's why we are now investigating Hadoop cluster. We plan to, in the next year or two probably, I say long term, 1 year or two is actually long term in this line of business. And Hadoop cluster should have one nice ability. If you add nodes, it actually will become more and more performant because it will add to the parallelization. So it should be the slowest in the beginning, and the more data you have, the more faster will it become, which is a nice ability. And we are, as I said, we are researching it. We don't have any too much of a case study. At this point, we calculated that it's better to buy bare metal machines than to go virtual because of the storage costs, etc., and because of the easier scaling out. Okay, I believe that I covered the whole story. Okay, that's it. Oh, okay. Anyhow, I would like to reflect once again on something that all other presenters said. Just have fun with whatever you're doing. If you are not having fun, you are doing something wrong. So basically, that's something that I think all of other presenters said at some point in their presentations. They were having fun sooner or later. So I must agree with them. I just wanted to say that, and thank you.